Hello, and thank you for listening to this episode of the Night Sky Podcast. My name is Billy Newman.
And I'm Marina Hansen.
And today we're going to be talking about the changeover to the spring equinox that just happened a couple days ago, the new full moon that we had, the eclipse that we had.
Yeah, I just had that this morning, right?
Yeah, a couple active things going on the last couple days.
Pretty active.
Yeah.
It's a little bad weather here, though. So we didn't really get to catch the eclipse this morning.
Yeah, no eclipse visible for us. I think it was most visible for people on the West Coast before dawn. And I'm sure there's a lot of people that got a good viewing of it earlier today, or anybody like that's down in California probably got a way better chance to get a chance to see it. But here in the Northwest, it was pretty cloudy over in the West on the horizon. We had a little bit of sunshine this morning, which I think was a surprise, but the rest of the day, it's kind of been on and off again, rain.
Yeah, pretty gloomy here in Little Eugene.
So we missed out on the eclipse that happened, but yesterday the moon rose as a full moon in the constellation of Libra. That's where it is right now. And I guess so we had the lunar eclipse, and that was at like 4 a.m. Pacific Coast time. You could see it before the sun rose, and then I think just as the sun rose and as the moon was starting to set is when you could see it, which was kind of a cool thing. I was looking at that a little bit. It's sort of rare for that to happen, for the sun. And I mean, it sounds illogical when you say it almost, but for the sun to be up and visible in the sky, and then for the moon to also be up and visible in the sky, but for the moon to be eclipsed is like a really rare but possible event.
For them to be lined up like that?
Yeah, so that you could be standing on the earth looking out eastward toward the sun and westward toward the setting moon, and have the moon be eclipsed, but you can still see both bodies at the same time. It's weird that there could still be a shadow cast onto the other body, but you can see them both at the same time. It's sort of a perplexing kind of thing that can happen. But I think that was a possibility today, is that as the sun was rising here on the West Coast, there's a chance for you to see the setting moon as it was eclipsed, or as it was dark. It's really cool. It's kind of interesting how that works.
That is cool. And so that's that just happens sometimes, but there are other eclipses that we have where it's not lined up like that.
Right. Well, I think in a lot of places, so for there to be an eclipse that exists, there has to be a thing called a syzygy, which is a cool word to spell. It's like SYZYGY or something. But or that doesn't spell what I think I'm trying to sound out. But a syzygy is a word that's a connection of 3 celestial bodies and like some kind of alignment. So for an eclipse to happen, what we're looking at is the sun to be out there, and then for, in this case, a lunar eclipse, the earth to occult the sun in relationship to the moon, so that the earth moves directly in front of the sun that is out past behind the earth.
Right.
And then therefore the large shadow of the earth is cast all over the moon. So that's why we get more total lunar eclipses than we get total solar eclipses. Or at least that's part of it, is that like for us, we'd see a partial eclipse of the sun in some parts of the earth, because the moon is so much smaller than the earth, right? The moon's shadow is cast, and that would look like a dot that's kind of darkened on the surface of the earth, where the line of the solar eclipse would be. But in relationship to the moon, right, since it's a smaller body, then the moon will just be cast into the earth's shadow for a much longer period of time.
Right.
So that's where we get hours of an eclipsed full moon, but we get only minutes of an eclipsed sun.
That's interesting.
Yeah.
Yeah, that makes sense. So it works that way.
Yeah, it's interesting how it works. But the whole system of eclipses on themselves is a really interesting and complicated cycle that I really don't understand yet. I've been trying to do research on it and trying to like figure it out for this podcast, so that we could talk about how the cycling system of an eclipse works, because that's some part that I've been interested in, but I never really had a concrete understanding of how to predict, or what is the prediction system for finding out when an eclipse is going to happen, or why is it that we don't have an eclipse every single month, right? I mean, the earth and the sun and the moon are all going to find themselves into some point of conjunction every month, right? We get a new moon and we get a full moon in a cycle every month. So there should be a solar eclipse on every new moon and a lunar eclipse at every full moon, you would think, because the bodies are just lined up to each other. Does that make sense to you?
Yeah.
And so the reason that does not happen is actually pretty peculiar. So there's the ecliptic line, and the ecliptic line is the path that the sun takes through the stars throughout the year. And so that's where we get the zodiac constellations that we follow, or what would that be? The constellations of the ecliptic, to bring it outside of astrology terms. But so what we see then is the moon doesn't follow the ecliptic exactly. It's got like a 5.9 degree shift from the ecliptic, and it sort of cycles back and forth above 5.9 degrees, like above, or 5.5, 5.5 degrees above the ecliptic line. And then, so it's like an ascending position of the ecliptic, and then below the ecliptic, which is a descending position on the ecliptic. And so it does this twice a month. And this is called the draconic cycle.
Right. You've mentioned that before.
Yeah. And the draconic cycle, or a draconic month, is the period for what's called a node to occur. So it's a position of, oh gosh, there's so many terms in this to explain. And this podcast is going to be full of me really not understanding the full depths of stuff, right? Because there's so many different systems and different like cycles that we're going to get into in a minute. So the draconic month, we talked about sidereal months, I think a few episodes back, when we were talking about like the lunar new year and the lunar system, and
right,
how the moon comes from full to a new moon and then kind of back again. So there's a sidereal month, which I think is like 29 and a half days. And that's a new moon period to new moon period. And then there's this draconic month, which is like 27 and a half days. And it's not exact. There's so many different, there's an anomalistic month, and there's like a sidereal, and what's a synodic month? There's that one too. There's so many things to get wrapped up in. The two we're going to focus on is sidereal months of 29 days, let's round, and then these draconic months, which are 27 days. Now, the way this draconic cycle works is, as we mentioned a second ago, there's this 5.5 degree shift that the moon has on the ecliptic plane that we see around the Earth, which is the ecliptic is the path that the sun takes. And so what happens in this draconic cycle is that the moon will move from a high position, 5.5 degrees outside the ecliptic, down to what's called a node. And a node is the term that they use for the intersection of the ecliptic line of the sun and the orbital path of the moon as it crosses and intersects at that point. That's called a node.
Oh, that's interesting.
So as the moon drops from its 5.5 degree height of its offset from the sun and the ecliptic line, it'll cross through that diagonally. And for one point, it'll be at a node. And this is the only point that an eclipse, either solar or lunar, can happen, is right when the moon is at a position of being in a draconic node.
Okay.
These happen twice a month.
I was about to ask.
If I understand right. And so it will fall 5.5 degrees above at its max in the wave. Then it'll fall down to 0 at a node. And then it will descend to 5.5 degrees below the ecliptic, and then back again to a new node at 0, and then back again to an ascending peak at 5.5 degrees above. Does that make sense?
I think so.
It's so complicated. And so that happens every 27 days.
Okay.
But that's different than the sidereal month of new moon to new moon, which is every 29 days. And so what we see is, if we had an eclipse, like we had an eclipse today, it'll be 27 days from now that we'd have the opportunity for an eclipse, when the moon is at the position of its draconic node, right?
Okay.
That's the next time it'll happen. But the problem is, the reason that we do not have an eclipse every month, like we're talking about, is that the moon is not yet full. Or it's not back to its same position in the cycle, in its sidereal cycle. That takes another 2 days. So the moon is not in the position to be eclipsed yet during that time.
Okay. So that would be a time that we wouldn't get an eclipse.
That would be, yeah, that's like why there's so many months out of the year that we would not experience an eclipse, or why there wouldn't be something going on. And eclipses only happen at these times where the node, where the moon is in the exact right position to be eclipsed by the shadow of the Earth.
And what's the name for that? Or is there a name for that cycle when those two things line up, right?
Yeah, so there's a few different things to understand. So the early system that I understand for how people started to get a handle on the way that these eclipses would work. I think they were, I'm sure, very interested in solar and lunar eclipses, trying to understand why they would happen. Lunar eclipses are more frequent and they were well tracked. Solar eclipses are sometimes more difficult to see, but are also common, and over centuries or over a lifetime, they would start to appear more often. And I'm sure people had religious beliefs or cultural meanings put toward them, through their groups of people that they were with. And so I think over time, the older people would start to pass down sort of the system or the last time they saw one, or how that would work. And there's a lot that I found out after looking into how eclipses work and why it seems so sort of haphazard the way that they fall. But it's also interesting though that, we really do have it planned out very well, and it happens exactly where it's supposed to, when it's supposed to. Closely, they shift a little bit. The predictions do shift a little bit, but they happen almost exactly when they're supposed to. And this is a thing that I think is measured, or at least the most accurate and oldest cycle for predicting the next eclipse is something called the Saros cycle. And I think it goes back to like ancient Babylon, like Mesopotamia, before the Greeks and all that.
Yeah.
I think there's talk of it. I think it's talk of it like 500 BC, which really isn't as far back as that. So I'm not quite sure. There's a person, there's a lot of record of someone predicting an eclipse in like 534 BC. And that was like an astounding thing. But they used this system of the Saros cycle that had been kind of figured out before by the Babylonians. And so this Saros cycle is really pretty peculiar. So let's go back a second when we talked about this 27-day cycle of a draconic month, and then this 29-day cycle of a sidereal month. So we have those two numbers in our head. Those are not the same numbers. But what we find out, and if I didn't do enough math to ever really understand what I'm about to talk about, but it's pretty simple. There's common integers, right? So what's a number that works for both 27 and 29 as you kind of multiply it out? Or does that make sense to you?
Yeah.
So I guess what happens is every 18 years we get to a point where this cycle that we were talking about, this 27-day cycle and this 29-day cycle, actually wrap themselves back out so that they're in the exact same positions as they were 18 and a half years before that. So yeah, so this is this thing that happens. So if an eclipse occurs, and I'm not confident enough to say if like an eclipse like today occurred. I'm not quite sure about lunar eclipses or about how that system works specifically. But let's say like the 2012 total solar eclipse that we viewed in California.
Right.
That one, that's the best example for you and I to discuss, I think, because I'm most concrete about understanding what happened there.
Right.
So using this Saros cycle, what you could say is that you could predict that in 18 years and like 8 months or 6 months or something after that, it's a really specific amount of time. I'm silly for not having that written down. But 18 years and so many months after that, it's going to repeat itself. But it's going to repeat itself in sort of an off way. So it's like 18 hours, 8 months, and 8 hours. And so what happens with that 8 hours, right, is that the sun can go from being up and visible to where you are on the planet and viewing the eclipse to a position where it's below the horizon. But in 18 years and 8 months, it is sending an eclipse out across the land in sort of a predictable way. Does that sound right to you?
Yeah.
Yeah. So what happens is since it's since there's this 8-hour shift that happens every 18 years, what happens is that I think it's like 53 years, or it's like every third 18-year cycle, there's this thing that I think it's called an excalmos. Oh, it's some Greek word that means like a completion or like some kind of cycle completion. But that's when, if you multiply 8 by 3, right, we get to like close to a full day of hours. And so that's this prediction that says that the eclipse will happen above you in the same position it happened 53 years before in your lifetime. But that will predict like that period when the eclipse will happen in almost the same position again on the land.
Oh, interesting.
Does that sound right to you? So yeah, so like, let's say, what would it be? Like if we're here in the US and we watched that eclipse above us in 18 and a half years, it's going to shift over 8 hours in the sky, like 8 time zones, let's say.
Sure.
Yeah, because it'll move that far ahead. But the next time it'll be over Europe. It's 8 hours past that. And then the next time around, it's almost back to exactly where it was 3 Saros cycles before, 3 18-and-a-half-year periods before.
Okay.
And that's when you would see it again in that
exact same spot.
That same spot is the idea.
Interesting.
But there's a lot of other stuff too. So not every eclipse that we see is part of the same Saros series, right? Because we have more than one eclipse every 18 years.
Right.
So there's lots of eclipses. And then there's lots of nuance to each of those eclipses. So there's like a trend in a Saros cycle. So you know, like the penumbra, the umbra, and then like the total eclipse position.
Right.
So on the outside, gosh, I hope I have this right. Yeah, I think penumbra is light shadow, and then umbra, dark shadow, and then total eclipse position, and then kind of fading back out to umbra of a dark shadow, and then penumbra of the light shadow. And so what I understand is that there's, gosh, it's so complicated how this works. So when an eclipse series starts, it starts near the poles of the Earth, either at the North Pole or the South Pole. And that's why a lot of solar eclipses happen up there. Like I've heard about like solar eclipse cruise ships. And so because there's so many solar eclipses that do happen, but they're not really visible on a continental piece that's easy to get to. So these people go on a cruise ship and they'll go out to the Arctic or something, and then they'll view this solar eclipse that happens out there. I think that's how the one in the Indian Ocean was a couple weeks back, is that people go out to the best spot to see it. Like how we did, we drove down to Reading, even just a few hours south, and it was a far better position to see a total eclipse. Where from here, we would only see a partial eclipse because we'd be far enough off on the angle of parallax that we'd still see the sun as it intersected. That's a really trippy thing too. So, the position of the eclipse changes, right, over the land where it is, but there's this way to predict where that's going to be. And it's depending on if it's an ascending Saros series eclipse or a descending Saros series eclipse. Ugh.
So how many different Saros series eclipses can be happening or are happening during the year? Yeah,
it's a good question. So I think a Saros series of like an eclipse's lifespan, there's so many. This is the part. There's so many different pieces of it. So wait. So ask your question again.
So how many different Saros series are going on
at the same time?
Yeah.
Okay. So I think that there are like around 200 going on right now.
Oh wow.
And I think that there have been 400. There's some count that goes out to like 400. But a Saros series in total of like the lifespan of an eclipse. So like we were talking about a second ago, they start out in the North Pole or the South Pole. And then depending on whether they're an ascending series or a descending eclipse, like, so remember when we were talking about the draconic cycle as the moon moves past its node from high position past the node and intersects, that's descending as it moves down. But as it moves up, it's ascending. And that position, whatever node it's intersecting, is going to be the node that it follows throughout its Saros cycle, because it's exactly the same position of the planets, of the moon and sun 18 and a half years later. It's the same node moving across the same position. And so because of this, it's really predictable how it's going to move. And so if it starts at the North Pole, it's going to move south until it moves across the South Pole and then is no longer an eclipse series that's available for us to view. Because see, like, as we understand it, everything's casting a shadow all the time. And so when we get an eclipse that we see, it'll start at the North Pole, then 18 years later, it'll move, I think, a little bit south from that position, and then a little further south still, and a little further south still. There was an article I was looking at. I think it was covering an eclipse that happened in 2003, and it was covering that eclipse Saros cycle from start to finish. It kind of outlined it. And so a Saros cycle is about 1,200 years to 1,500 years long, the lifespan of the eclipse. Okay. So every 18 years of that 1,500 year period, an eclipse will happen on that cycle as the moon moves through that position or that node in the draconic cycle. So many cycles.
Interesting. Yeah, tons of cycles. That's a lot to keep track of.
Yeah. So the one that we saw, I think in 2012, I think that's going to be further south next time.
Yes, I think so.
Maybe that's what's going to happen. So yeah, when we see that one again in 18 or what are we at now? 14 years from now, 15 years from now, in another 15 years, it's going to be like either out in the Indian Ocean, probably. Maybe it moves westward. I can't remember if it would move westward or eastward. It'll be in the Indian Ocean or it'll be in the Gulf, and it'll be further south of an eclipse line than where we saw it. So it's really strange how that happens to be.
It is.
I don't get it. Or so this is the other part that I'm trying to figure out, because there's these smaller eclipse cycles. Not every eclipse happens in that 18-year period. There is a chance that it could happen in between that period and still be an eclipse that would be part of that cycle. But it depends. This is what I don't understand. So there's something that happens that changes, I think specifically for lunar eclipses, that causes abnormalities in the cycle, like things like tetrads, which is what we experienced over the last 2 years. Do you remember that? There's the 4 total lunar eclipses over North America in sequence, separated by 6 months, which I think is the least amount of time that's possible for reoccurring eclipses, is a 6-month period. And I think that's because, well, how is that? It's like 6 lunations. So it's not quite 6 months, but it's 6 full moon cycles later is the next time that it would be in a position to be at a node.
Okay.
I don't get it though. But I think that might be part of a different Saros cycle, because those 4 won't happen again in 18 and a half years.
Yeah.
Does that make sense? So I don't know how that works. The tetrad thing is something I don't really understand. This collection of 4 back-to-back eclipses is still something I don't understand. Another part I don't understand is eclipse season. It's this other term that's out there that I barely understand, because eclipses can happen, I think, at any day throughout the year. But I think that there are periods where they are more common to happen. And I'm not quite sure why that is, but in my life, I think I've only really observed lunar eclipses near the equinox, or near the position of lunar equinox. So like if you look like during the tetrad, it was all like April to October, and then late March to September. Like it was all separated so that it was all really close to what would be the autumnal and vernal equinox. And then for solar eclipses that we've seen a lot of those during the solstice. Like, so we saw that one at the end of May. I remember seeing another one was in high school that was in June. I remember we went out when I was in college. I met up with Robert and we went out to Williams to watch a lunar eclipse in December. You and I went out to watch a lunar eclipse in December once. That was a few years ago. That was back in 2000.
I was trying to remember now.
That was December 2011, I think.
Yeah.
And we drove up to Mary's Peak to watch that. Yeah. And I remember seeing it with you. Yeah. I remember watching it turn dark and all those other cars out there. And I remember being freezing cold. It was like 4 a.m. when that eclipse came out. Oh man, it was too chilly. But yeah, that was a cool, I think it was a total eclipse, or real close to total eclipse. But that was really cool to see too.
Yeah.
Yeah, real strange. So, gosh, I hope I didn't make it just way more confusing to try and think about these like 18 and a half year cycles.
There's a lot to it.
Yeah, even just understanding the draconic month, and that the moon, like, I had wondered for years, why is it that the moon and the earth, why we not have eclipses all the time or constantly? I mean, like, you just think it would happen more. You think the Earth's shadow would be large enough that at some point when it passes around in opposition to us, it would hit the shadow. But it doesn't, because of this 5.7 or 5.5 degree tilt on the axis of the ecliptic line that the moon kind of travels through as it moves around. And it's a really strange sort of intricate, well, it's not that intricate. It's really simple. It's sort of like a hula hoop as you like kind of like let it on the ground, and it sort of wobbles around, or like at the top of a lid as it wobbles around on the countertop until it stops. It sort of wobbles around in the same way across the ecliptic line. So right now the moon's in Libra, and that's where we had an eclipse. So the node position would be there, but the next month, because of this kind of 2-day gap between the draconic 27-day period and the 29-day sidereal period, it just kind of rolls by 2 days each month, and then by 4 days the next month, and then by 6, and then by 8. And so that's kind of why it gets off. And then I think that's probably why, I don't know, it's probably why it takes such a long time to get back to the position where you could have an eclipse again. But it was cool. So I don't know, some of the eclipse stuff that we've been trying to follow. And man, those cycles are so tough.
Pretty tough. Definitely more to learn about.
Yeah, we should get into more eclipse stuff in the future. I'm still trying to figure out, like the Metonic cycle. I was trying to figure out, what did the Metonic cycle mean when we were trying to figure that out? That was a 19-year cycle. And I was trying to sort this out in my head. That's only to figure out the period of a true year around the sun as a 364.5 day period. That's like that proof of how long a year is, because that's the common integer. What is that? The common? Oh yeah, of a synodic month and a sidereal month. I think that's a common integer of that. That's why we use it. Yeah. So that kind of reconciles the lunar calendar period and the solar calendar period, so that it kind of tries to keep track with those lunar calendars that we had talked about that sort of get off with their lunations because they happen at different times. Right. You'd all of a sudden start having your summer be way into fall if you kind of stayed with the wrong calendar for too long. So that's why they put in like leap months into those lunar calendars. And so that's why the Metonic cycle is something that we talk about. But then the Saros cycle is just for eclipses and just for the draconic nodes and the positioning of the moon and on the node and the earth and the sun. So strange how that works, but there's so much more to learn about that stuff. We should talk about a nice note that we got.
Yeah. Thank you very much, Jason.
Thought it was really cool. Yeah, that is 2 different continents that we've gotten comments from.
Hey.
In 10 episodes, Marina.
Nice job, Billy.
Episode 10, and we've already got, presents on 3 continents.
Ooh. Pretty cool. Yeah, thanks a bunch for the encouragement and cool comment.
Yeah, definitely still finding our podcast legs. Shoot, I'm just trying. Gosh, I can't talk about Saros cycles all this time. It's so complicated. I don't understand any. I have like a high school education in astronomy, so I appreciate that anyone from somewhere else is listening to me talk about what I wanted to look at in the night sky. Pretty cool. So yeah, definitely keep sending in some messages. That's pretty fun. Send in like topics or like things that we should try and discuss too, because I'm probably going to run out.
Please feel welcome to ask questions or suggest things that you want to hear about.
They'll figure it out way faster if they just Google it.
Probably.
Yeah. Jason was talking about, we call the last episode Viewing Canopus, and we talked a little bit about our trip while we were in Hawaii, getting to see Canopus for the first time, looking south of Sirius and seeing like a star that you could just never have seen before. And he dropped a couple lines for it because he's in Australia, right? And so he was, I guess he's lived there and not in the northern hemisphere. So he was kind of commenting on that idea of how we have our northern constellations, northern hemisphere sky, and then the southern hemisphere sky, and just how we both don't really get to see the other person's sky. We don't get to really experience that. And so we, like myself, I always wonder, like, what is Canopus like, or what is just Centaurus, like what does that look like, or what's like the Southern Cross look like, or what's the Magellanic Clouds look like? Any of that stuff I've never got to see, and I think it'd be really cool. And then likewise, what he was saying in his comment is that he sort of thought about the northern sky, which I don't take for granted. I think it's great and it's really beautiful. But he was like, I wonder what the Big Dipper looks like. I've never seen the Big Dipper. So that'd be really cool to get to like see this thing that's so talked about and experienced by everybody. It seems it's the only thing people know in the sky. He could see Orion from there, and Scorpio and a few other things. But like, I think it's like, the most popular, most well-known thing in the night sky, at least in the northern hemisphere, and that's something that they don't get to experience down there.
That's really interesting.
Yeah, cool to hear about. And thanks for sending that in, Jason. I appreciate it. But I think that wraps up just about everything we were going to talk about on this episode of the Night Sky Podcast. I think so, right?
Yeah.
Any other comments or so? Oh, you guys, thanks for sending in a comment. What was I going to say? Oh yeah, rate, review, and subscribe this podcast, or subscribe to this podcast on iTunes or whatever you guys use. Appreciate the comment. I think anything like that works out really well. But yeah, we're